In this video, we will go through the step-by-step process of creating a project and running a Monte Carlo analysis in PSpice. During a Monte Carlo analysis, PSpice performs several simulations, each time varying component values randomly within a specified tolerance range. At the end of the simulation, we'll be able to analyze how the tolerance of a specific component affects our desired output. So first we will start off by creating a new project. So we will go to File, New, and select Project. We will name the project Monte Carlo and select Analog or Mixed AD. Since this is a new project, we will create a blank project. First thing we do is create our desired circuit. In this example, we'll create a tank circuit which has a general application that can be used as a radio transmitter. So here we will vary the tolerance of the resistor in the circuit and see how it affects the output impedance. So to do this, we will first need to place our components. We go to the main toolbar, select Place, and then Part. So first I will get an AC voltage source, since I will be running an AC analysis. So we do that by typing in VAC and select the AC voltage source. And I will rename this component by double clicking the reference designator and calling it VSource. I will choose a capacitor, an inductor, and a resistor. Okay, so now we have all of our components placed on our circuit. We need to connect the wires. And to do that, we choose Place Wire. And here we'll make all of our connections. And then select End Wire. And I chose this command from the quick toolbar here on the right, but you can just as easily choose Place in the main toolbar and then Wire. So here I will change the values. Okay, so we have all of our components and the specified values, and then we'll finally add a ground to complete the circuit. So to do that, we choose Place and then Ground, and then select our ground. And we'll also connect that in. So here we have a completed circuit. And as we already described, the Monte Carlo analysis will rely on component tolerance. So here we will have to see where can we specify the component tolerance for our desired component. We'll choose the resistor R1, and to set the tolerance we'll double click the component, and then we'll see a set of parameters, and we'll scroll down until we find the tolerance column. So here in the tolerance column we'll choose our tolerance and we'll set it to 10% to start off with. And then we'll choose Display so that we can see it and easily change it on the circuit. We'll save that, and then we can close out. So here we see that the 10% tolerance has been assigned to our resistor R1. So now we have our circuit created, we've assigned our tolerance to our desired component, and now we can run the simulation. So to do that, we will go to the pSpice command on the main toolbar and select New Simulation Profile. So here I will name the simulation Monte Carlo, and then choose Create. So this is the main window for any simulation that you would run in pSpice. The first thing you would do is choose your analysis type. So here, since we're running an AC analysis, we'll choose AC sweep. And you will fill this in just like you would any AC analysis that you're running. I'll choose 1 kilohertz to 1 megahertz and 1,000 points per decade. The more points per decade you have, the better resolution you'll have on your output graph, but it should be a reasonable amount so that it does not slow down your simulation. Okay, so once we've chosen all of our values for our AC sweep, we'll go down and choose Monte Carlo / worst case in the options window. We must make sure to enable this simulation by enabling the check mark. So here we see our Monte Carlo analysis parameters. The first thing you would do is select the number of runs. So Monte Carlo will run random simulations for a specified number of runs. So here we can choose as many values as we want, but to keep it reasonable, we'll select 10 to start off with. And you also have the choice of running this as a uniform distribution or a Gaussian distribution. So we'll start off with uniform. Random number seed just tells the simulation where to start. We'll choose 1. And we want to save all the data. So this is enough to give us our output plot in graphical form. But if we want to look at the data in a text file, we go here to the output variable and select which output variable we'd like to see as a result of our Monte Carlo analysis. So in this case, we choose output current. So we'll type in IV source. And here we'll go to More Settings command at the bottom of the screen, and we'll see a list of different values that we can have outputted in our text file. So here you'll see Ymax, which finds the greatest deviation from nominal, max, which finds the maximum value with regard to nominal, min, which finds the minimum value with regard to nominal, rise edge, which finds the first positive going crossing of the 0 axis, and fall edge, which finds the first negative going crossing of the 0 axis. So for our simulation, we'll choose min. So once we select that, we hit OK. Now we have all of our options selected, and we can run our simulation. So here we'll choose Apply, and then OK. And then we can go to the Run command, which is this green play button in the quick toolbar. Okay, so here are all the different simulation runs, and they're already highlighted. We want to make sure that they're all highlighted so we can see each and every run. So here we select OK. So here, since we ran an AC analysis, we see a frequency response on the x-axis. And to output our results, we go to the Trace option in the main toolbar and select Add Trace. So here we want to see our output impedance, and we'll see it in decibels. So we choose the decibel command from the functions window, and then we can pick voltage divided by current and select OK. So here's the overall view of our results. We run a frequency sweep and we can see the impedance at the different frequency levels. And just to get a better idea of the different results, we'll zoom in to the peak over here. And if we counted, we would see that there are 10 different results shown based on the 10 runs that we selected in the options. So that's basically what you'll see for your different results. If you chose 1,000 runs, you would see 1,000 different traces in your output. So let's say we want to see our output file in text form. We go to the View command in the main toolbar and select Output File. And here we'll scroll down until we find our Monte Carlo simulation results. And here they'll be in the section titled Monte Carlo Summary. So here we see each of the random runs and the minimum value of the output current and at which frequency it occurs. Again, this is the value that was chosen in the Monte Carlo option setting for output summary. So that concludes a basic introduction of Monte Carlo analysis. We can go back and change a couple values to see the different types of distributions that we have options of choosing. So to do this, we will go back to our PSpice command in the main toolbar and select Edit Simulation Profile. Go back to Monte Carlo analysis in our AC sweep analysis type. Here we can also increase the number of runs to 15, and then we'll choose Gaussian. And here we'll click Apply and then OK. And here we can also change the tolerance just to get an idea of the different changes we can make to our circuit. So here I'll choose 25%. So we'll run the simulation. And here we'll see that there are 15 runs because we changed the number of runs to 15 from 10. We select OK. We can add our trace. Choose dB, D source divided by IV source. And here we see our output and Gaussian distribution. Again, since we increased the number of runs to 15, we will see 15 different traces in the output window. So that concludes this tutorial on Monte Carlo analysis in PSpice. This simulation or this analysis type can be run on multiple simulations. We'll go back and it can be run in DC sweep, AC sweep, and also transient. But we'll leave that for another video.